All right, class, let's look at the homework for lesson 9-3, polar and rectangular forms of equations. Hopefully this homework went well for you. Here in number 1, we are given a polar coordinate. Remember, this is our distance, and this is going to be the directed angle. And so that's going to be a polar coordinate, the distance from the origin at that directed angle. So this will be at 45 degrees. And we want to get the rectangular coordinates. Well, when I say 45 degrees, you think unit circle as well. You know the cosine is root 2 over 2, and the sine is root 2 over 2. But that's for the unit circle, where the distance from the origin is 1. When the distance is 2, that's going to knock out the denominator. All right, but let's do that mathematically. We know that intuitively, or hopefully we do, but let's do it mathematically. We know that x value is the directed length. We'll call this r. This is our r value times the cosine of theta, because cosine is our x value, sine is our y. And then when we substitute these values in for r, and this is theta, cosine of pi over 2 is root 2 over 2 multiplied by 2. The 2's cancel, and we're left with a root 2. The exact same thing would happen for the sine. Let's look at number 3. We have a distance of 5 from the origin at a directed angle of 240 degrees. And so here's our theta, and we just use our formulas. What's the cosine of 240? Well, that's going to be 30 degrees clockwise from 270. That's going to line up with my pi over 6 from my quadrant 1. So you could use your left-hand trick there and know kind of where that's going to be. If it's 30 degrees, that's going to be 240. That would be 30 degrees clockwise from 90, which would put you at 60 degrees. 60 degrees. All right. Sorry, guys. I was looking at that thinking, I was talking and thinking, that's not right. This should be 4 pi over 3. Right? Because it's going to be, I'm just thinking logically in my head, if it's 30 clockwise from 270 or 40 clockwise from 270, no, it's 30, forgive me. It's Friday, I need to stop this, don't I? That's going to be, if I go to the upper end of the unit circle, it's 30 degrees clockwise from 90, which puts it at 60, and I know that's pi over 3. This should be 4 pi over 3, because I know in quadrant 3, I take the denominator and add 1 to it. So 3 would go to 4. So just picture a 4 pi over 3. But the rest of the math is correct, because if I'm dealing with the cosine of that, and I go to my pi over 3, the cosine of that is going to be 1/2. So this would be a negative 5/2, because I know the cosine in quadrant 3 is negative. So if the cosine of 4 pi over 3 is 1/2, then the sine is root 3 over 2. That's also going to be negative. So these are the rectangular coordinates for this polar point. All right, that was confusing. Sorry about that, but that is 4 pi over 3. Number 13, they give us a rectangular coordinate and they want us to go to polar. So we remember that r is equal to x squared plus y squared, square root of all of that. All this is Pythagorean's theorem. That's what we're dealing with here. We're given the x and y components of a right triangle, and we're going to solve for the hypotenuse. That's all that's doing. Then the theta, this is just taking tangent of theta, it's opposite over adjacent, and we're doing the inverse of it. So we're just playing on our trig functions and our Pythagorean's theorem. So once I plug in and execute the math, the r value is 12.21, and the angle is going to be 0.96. So 12.21 and 0.96, that's radians. And so we want to get the other end of it, the back end of it. So instead of positive, we make it a negative 12.21. To find that number, we have to add pi to my 0.96. So the back end of this thing is negative 12.21 and 4.10. Let's look at 16. They give us 4 and negative 12, exact same process. So my r value is 12.65. My theta is negative 1.25 radians. And so there's my coordinate. There's my first polar coordinate. I have to add pi to it as well, and I get 12.65. That actually should be a negative 12.65 and 1.89. So I'm going to have a positive and a negative, kind of the front end and the back end. Hopefully that makes sense. If not, send me your questions. On 25, we've got this nice little drawing here. We've got an angle From this point to our origin, it's 50 degrees from the north and 1.5 miles away. I think this was a concert hall or something. And here we have something else. I don't have my book in front of me, but it was 0.5 miles. This distance here, it's 2 miles west and 0.5 miles south, but this is more of a direct shot of 1.5 miles. And so what we want to do is first is, what is theta? What is theta? If this is 53 degrees, then I know my theta here is going to be 37 degrees. And so I know tangent of theta is y over x. Well, I don't really need that, do I? Because I'm trying to solve for my x and y. So let's just go to sine. Sine of 37 equals y over 1.5. And so now I can break this directed vector, all right, if you will, a directed vector. I have a vector, and by being a vector, it has a direction. That's part of what makes it a vector. It's not the right way to say that. But I take this vector and I break it into its component forms. My y is 0.9 miles. My x is 1.2. So it's 1.2 miles east and 0.9 miles north. That was the first part of their question. B, what's going on with this one? What are my polar coordinates here? I know my x and my y. What is my polar coordinates? What is the vector that's going to go from here directly to this point? Well, this is where I use my r equals root x squared plus y squared, and I'm able to solve. So it's 2.06 miles from the origin directly to this location. What's the directed angle? Here I need to use my tangent. And so once I do the inverse tangent of y over x, I get 14.04, but think, I've got to add 180 to this because it's way over here. I've got to add this 180. Remember, the theta is going to be measured from the horizontal, from the east. So it's given me this portion. This is also helpful to see is why you would add 180 at times. I need all of this 180 added in there. So the theta is 194.04 degrees. So this would be your polar coordinate for this other location. 36, we have r equals 3 sine of theta. And we're going to be rewriting this and see what kind of shape this is. Well, I know that r squared is equal to x squared plus y squared. So why don't we take this and multiply both sides by r? That's what we're doing here. If I multiply everything by r, you see the r show up right here, and then this becomes r squared. Once I do that, I can substitute what r squared is equal to in the equation. Now the r squared is gone, but it's been replaced with this. Another substitution. I also know that r sine theta, that's how I find my y component. So now I'm left with x squared plus y squared is equal to 3y. Well, if you bring 3y over, look at this expression right there. All right, now this is helpful. This is showing us what I've got now. All right, so use completing the square. Half of 3 is 1.5. Square that, you get 2.25. Add that to both sides. That's just completing the square. Then I can rewrite it with a sum of squares. And I can see here that this is a circle. It's x squared plus y squared equals the radius squared. So this circle is going to have a radius of 1.5. It's going to have a center point of 0 and 1.5. So this expression right there, through some crafty substitution, I can see that's a circle with a radius of 1.5 and a center of 0 and 1.5. All right, last two problems. Let's look at 37. Here, instead of giving us just the r value, they've given us just the theta, negative pi over 3. So I'm going to drop clockwise from the horizontal, and that's going to get me to 5 pi over 3. Well, I know the coordinates for 5 pi over 3. The cosine is 1/2, and the sine is negative root 3 over 2. I hope and by now you're seeing just how helpful that unit circle is. Makes your life so much easier. I did not overstate that several months ago when we were learning the unit circle. So I want to find let's use the tangent. All right, the tangent theta is going to be opposite over adjacent. So here's negative root 3 over 2 over 1/2. And I can simplify that down to negative root 3. Well, let's come back to our equation. Tangent of theta is equal to negative root 3 over 1. But I know that tangent theta Let's do some more substitution. Is y over x. It's equal to y over x. So how about we replace it to get rid of the tangent? And now I'm just dealing with y over x. Just cross multiply. And you get y equals negative root 3 x. That's a line. Can you see that? That's y equals mx plus b. That's at the origin with a slope of negative root 3 over 1. So it's a line. So this, when they just give us that directed angle, we're going to be dealing with a line. And that's how you define that. 46, they give us just an r value, 12.6 sine of theta. Once again, we know if we multiply both sides by r, we end up squaring this r value. We can then substitute it with x squared plus y squared. Once you bring this to the other side, you're left with x squared. Well, I didn't just bring it over. Here's another substitution, r sine theta. Remember, that's equal to y. So I substituted again. And now look here, another circle. And once I use completing the square, I'm able to, and look, this is your r squared value, right? And this was the one, if I'm not mistaken, that dealt with, I think, an earthquake. And they were asking us what this information shares. So this is a circle at 0 and 6.3. And then it has a radius of 6 let's see here. What was the radius? Was it 6.3, right? It has a 6.3 radius because that's the r squared value. And so what it's saying is the quake was felt within a radius of 6.3 miles. That's what this information is saying. So there's actually some practical use for polar coordinates, believe it or not. All right, guys, I hope this was helpful. I know I went through that somewhat quick. If you have any questions, make sure you send them my way.